Spectroscopy is the process of using light or electromagnetic radiation to analyze the characteristics of matter. How is this possible? It's based off of an important fact. Light can be separated. More specifically, light can be separated into specific wavelengths, using prisms or, in more modern times, diffraction grating. Through this process, light is developed into a spectrum, and one can use this spectrum to understand how certain parts of the spectrum interact with material or structures of different types of matter. This process was an important part of early 20th century physics, where it was used to learn more about the atomic structure, but it still has many uses today, such as MRIs and X-rays. For my project, I decided to create a basic spectrometer. How does it work? It consists of a bipolar stepper motor used to rotate diffraction grating to shift parts of the light spectrum, a slit structure for the light passes through, and an op-amp photoresistor circuit to detect changes in light output. The process is relatively straightforward. Light from a light source is sent and split through a diffraction grating, and different light wavelengths are isolated via a narrow slit. Behind the slit, the substance of choice is in a beaker with the photoresistor directly behind it to detect changes in the light signal. Because input fluctuations are so subtle, an op-amp circuit was used to amplify the signal to detect the changes. Then the input signal was measured using a multimeter to measure the output signal in voltage of the op-amp. The motor was controlled by Arduino. It iterated through a series of subtle rotations corresponding to shifts in the wavelength, where in each rotation I measured the resulting output signal along with its corresponding color. A lot of adjusting and troubleshooting was involved in this project. I had multiple models to work with. The original model used an optical sensor from an optical drive. This was the original idea, but due to issues getting the right model, I had to adjust for time purposes and work to create a different model. Instead of using the optical sensor, I went with another version in which a photoresistor op-amp circuit was used instead to capture light changes. I also had to do a good amount of calibrating and troubleshooting, most of which was involved in splitting the light source. The first challenge was finding a good light source with a high enough intensity. I experimented with LED lights, incandescent mini bulbs, but found that the only light source that had a high enough intensity for diffraction was a flashlight. In addition, I originally used a CDS diffraction grating, but then decided to purchase linear diffraction grating for better precision. I had to adjust the slit length as well and position for all the components. Due to the sensitivity of the photoresistor, I could only operate the spectrometer in the dark, where natural lighting won't interfere with the light source. I ultimately experimented with two substances, regular water and blue liquid. As mentioned before, the Arduino code enabled the motor to rotate every 3 seconds to allow enough time to observe changes in the output signal via multimeter. I recorded two signals. My main conclusions: the input signal was slightly lower overall by a difference of around 2 to 20 millivolts from the blue liquid than water, and that the input signal increased as a function of length. In other words, the signal increased as the spectrum progressed from blue light to red.